At first glance, to red giant Gruis, 530 light-years from Earth. Looks like just another aging star. But astronomers have suspected for decades that something strange was happening around it. Something they couldn't see. Gruis began its life similar to our sun, but now, at over 400 times the sun's size and thousands of times brighter, it's in its asymptotic giant branch phase. The final act before becoming a planetary nebula. In these days, the star pulses, manufactures new elements, and ejects enormous amounts of mass, sometimes the mass of an entire Earth every 4 years. With a star this huge and bright, detecting a close companion is nearly impossible. Any nearby object gets completely drowned in its light. But for the first time, using the incredible resolution of ALMA, the Otakama, large millimeter submillimeter, array astronomers have directly resolved the orbit of a hidden companion around Gruis. This is a breakthrough. Not only did ALMA detect the companion, it mapped its orbit, and what scientists found overturned previous predictions. Earlier models assumed the companion followed an elongated, elliptical path, but ALMA's observations show the opposite. The orbit is almost perfectly circular. This means the system is circularized far more quickly than expected, and that challenges our current models of how giant stars evolve when a companion is nearby. To understand the orbit, researchers first had to determine the mass of the giant star, using Gruis's luminosity and pulsation patterns. Astrophysicists at Monash University matched it to stellar evolution models, narrowing down the star's true mass and allowing the team to compute the companion's orbit precisely. The result: a closed binary system whose evolution is more dynamic and more violent than we thought. And here's the part that hits close to home. One day, our sun will become a red giant too. Knowing how close companions behave around stars like Gruis helps scientists predict what could happen to planets in our solar system, and how the sun will reshape its surroundings in its final life stages. This discovery also pushes researchers to revise the physics of tidal interactions and binary evolution core processes that define how stars live and die. ALMA didn't just find a companion. It opened a new window into the last, chaotic chapters of stellar evolution, including the future fate of stars like our own.